Good morning, everyone. Let me start with a simple thought. Every morning when the sun rises, it showers the earth with unimaginable amounts of energy. Have you ever wondered that in just 1 hour, the sun provides more energy to earth than the whole world consumes in a year? We call this the solar constant, about 1,367 watts per square meter. That means every square meter on earth, directly facing the sun, receives this much power. Mathematically, it is written as S equals P divided by 4 pi r squared, where P is the total power output of the sun and r is the distance between Earth and sun. So yes, the sun is a giant nuclear power station, freely available to us, and our challenge is, how do we capture and use this enormous energy efficiently?
Now, how exactly do we turn sunlight into electricity? The answer lies in the photovoltaic effect. When sunlight hits a solar cell, its photons carry energy. This energy can be calculated as E equals h into nu or hc by lambda. Here, h is Planck's constant, nu is the frequency, and lambda is the wavelength. If this photon energy is greater than the band gap of the semiconductor, usually silicon, it knocks electrons free. These electrons flow, creating a current. So, every ray of light is actually a messenger carrying tiny packets of energy that we can transform into useful electricity. Let's zoom into a solar cell. At its heart is a p-n junction made of silicon. When sunlight falls, it creates electron-hole pairs at the junction. The built-in electric field then separates them, electrons move one way, holes the other, and that sets up a current. Now, a single solar cell produces only a small voltage, about half a volt. To make it practical, many cells are connected together into panels. That's what you see on rooftops or in solar farms. And here's a quick fact. Even the best silicon solar panels today convert only 15 to 20% of sunlight into electricity. That means most of the sun's gift still goes unused, but technology is steadily improving. Where do we use solar power? The list is endless. Small devices like calculators and watches have used solar cells for decades. Rooftop systems now power homes, reducing electricity bills. Large solar farms spread across acres supply electricity directly into the grid. Imagine thousands of shimmering panels tracking the sun. And in many remote villages, where laying electric wires is difficult, solar panels provide the first source of reliable electricity. Isn't it amazing how the sun, the same source that lights our mornings, now also lights our bulbs at night? But of course, no system is perfect. Solar energy has its challenges. The sun doesn't shine at night, and clouds or dust can block sunlight. That means solar power is intermittent. Panels are also expensive to install, though costs are dropping fast. And to generate large amounts of power, you need vast areas of land. Another issue is efficiency. Even under strong sunlight, a big part of the energy cannot yet be captured. That's why storage batteries and hybrid systems are so important to make solar power reliable. Let's take an example to see how much power a solar panel can actually generate. Suppose the solar constant is 1367 watts per square meter. A panel of area 2 square meters receives this much sunlight. So, total power falling on it is 1367 multiplied by 2 equals 2734 watts. Now, if the panel's efficiency is 15%, the useful output is 0.15 multiplied by 2734. That comes out to about 410 watts. So, under ideal sunlight, a panel of just 2 square meters can run around 400 watts worth of appliances, say a laptop, a fan, and a few LED lights together. This shows both the potential and the importance of efficiency in solar design. So, to sum up, solar energy is abundant, clean, and free. Using the photovoltaic effect, solar panels convert photons into electricity. From tiny calculators to massive solar farms, this technology is already transforming our world. Yes, we still face challenges, cost, efficiency, and intermittency, but progress is rapid, and the future is bright, quite literally powered by the sun. I hope this session helped you see solar energy not just as a scientific principle, but as a real-world solution for sustainable living. Thank you for joining me today, and remember, the next time you feel the sun's warmth on your face, you're standing under the most powerful energy source humanity has ever known. See you in our next session with another fascinating concept of physics.